we have to solve for x first. So there are different ways to do it, but let's go ahead and bring everything to the left side, so everything will be on the same side. This is a quadratic inequality, so here I rewrote it as an equation, and now we'll identify parts A, B, and C. A is the 5, B is the 22, C is the negative 15. What you're doing is getting the quadratic formula. There are different ways to solve it, but this time the quadratic formula might just be the fastest way to do it. And you plug in the information. And then you simplify where you can. So here we'll put a 10 on the bottom. Underneath the radical, let's just find out what all of this is. So then you get 784. And now let's see if this is a perfect square. Just try it on your calculator. Try to find the square root of 784. If you got an integer specifically, then you know that it's going to work. You can find the square root of this. Now the square root of 784 is 28. So we have a very nice situation here where we have an integer. And this will simplify it a bit more. What's going to happen is that you'll split this up now, specifically where you have the plus version and then you have the minus version of this. And you just keep simplifying here. On the top, that's going to be a 6. And both the top and the bottom here can be divided by 2. So this ends up being 3 over 5. This is one of our critical values that we'll need. Here on the right, this is the same thing as negative 50 over 10. And this turns into a negative 5. Now we solved this equation for x, and we found a negative 5 and a 3/5. The next thing you have to do is create a number line. And a normal number line goes from negative infinity to positive infinity. Here, we'll put these in order. The negative 5 would go here. And the 3/5, we can just put that right over here. And now you go ahead and define the intervals. You're just taking it right from above. Here on this side, we have negative infinity to negative 5. Here we have negative 5 and 3/5. Here we have 3/5 and positive infinity. All the numbers have parentheses, by the way, because back over here, when this was an inequality, it's the version of the inequality where it's not equal to. It's just less than. So in other words, if you have one of these, it's the same as having an open circle or parentheses. But if it was the other kind with the bar where it's or equal to, then you have the closed circle and the brackets. So here we're dealing with the left side. So that's why these all have parentheses. And if I wanted to put this on the number line, I would give them open circles like that. We can just do that for now. We don't have to on this question, but that's enough. I mean, there's nothing wrong with doing that. Now, we defined our intervals, or we identified them specifically. They're based on the critical numbers. Then you go ahead and find some test values. From each interval, you're picking a number that fits inside of that interval. So here, you want to pick some easy-to-use integer. In this side, one number that would be easy to use is the negative 6 there. Here, if you can pick 0, that's a good one to pick. So this one will be 0. 3/5 is less than 1. So for the far right side, we can just pick 1. That's a good number to use as well. And then here, we're trying to find our result. There are different ways you can describe this third part here. You can break it up into another 3 sets of rows, but we're just looking for a result at the end of this. So here, what you're doing is you're taking the test value, and you have your choice. You can check it in the original inequality, or you can check it in the modified one here. I'm going to just stick with the original one. Or you know what? Let's pick this one, because we have a 0 on the right side, so this would be a good one actually. So I'll just write that one down here to indicate that this is the one we're using, 5x squared plus 22x minus 15 is less than 0. We'll be able to see our answer very quickly because of the 0 there. Now, what you're doing is you're taking the test value and you're plugging it into this inequality for all three intervals. So here you're going to put a -6 here, where the x is, here as well. And on this one, you can just skip to using your calculator. It would speed things up a bit. So 5 times 36, this is 180. Then we have a negative number here. 22 times 6 is 132 minus 15. 180 minus the 132 minus the 15. This gives you a 33 here. And it's saying that 33 is less than 0. This is our result. The result is that we have a false statement. If it's a false statement, then this interval up here isn't part of our answer. You're not going to use it. So in that case, we just need to know that this isn't going to be part of our answer. So we'll move on to the next one. Here, because of the 0, we specifically wanted to pick a 0 because it's going to get rid of all the variables right away. They're all going to disappear pretty quickly. So if you can use 0, it's a good one to pick because this is a 0 and this is a 0 now. We can see our answer very quickly. We're seeing a statement where it says -15 is less than 0. That's true because the negative number is less than 0. Now this means that we have part of our answer. I'll highlight it. But this -5 to 3/5, this is part of our answer. But we still have to check the last one. We have 5 times 1 squared plus 22 times 1 minus 15. We just need to know if this is less than 0. This is going to be 27 minus 15. So we got a positive number. 12 is less than 0. And our result here is that this is a false statement. So because that's a false statement, then this interval isn't part of our answer. We're not going to do anything with it. You see this part that's in blue? This is the solution set in interval notation. Remember what I said earlier about how if you have it like this, without the bar underneath it where it's just greater than or less than, then this one has parentheses. So in that case, on the number line, you just have some parentheses here. And between them, this area gets shaded. This is what it would look like on the number line. So using parentheses, you should see something like this.